Hello, bonjour, it's Laura here. In this video, I'm going to talk about different types of chemical reactions. So we've already talked about what a chemical reaction is and what you could look for when a chemical reaction is occurring, like look for bubbles, look for a color change. And then we've also talked about what's going on behind the scenes in a chemical reaction. So in this video, I'm going to talk about how you can classify different chemical reactions. So the different types of chemical reactions we're going to look at are synthesis, decomposition, single displacement, double displacement, and also combustion reactions, which we've also talked about a little bit in organic chemistry. So these are the types of reactions that we're going to be looking at. And then let's get right into it. Let's look at the combination reaction. So in a combination reaction, you're starting with two or more substances, and they're all going to combine to form one product. So let's look at an example of that. So if we look at magnesium, it can be combined with oxygen, and then when that happens, magnesium oxide is formed. So we've got some pictures here showing we've got magnesium, and then oxygen. So here these little red diatomic molecules, those are oxygen. So they're coming into contact with this magnesium strip. So see this curly metal strip here? That's the magnesium, and then this is a close-up of it in a lattice structure there. So when those two combine, then they form another lattice structure, but now you can see that you've got magnesium and then you've got oxygen elements combined into that. So we've started with two reactants and we've ended up with one product. So they've combined. All right, so that's what you would look for combination. Let's look at a decomposition reaction. So in a decomposition reaction, this is kind of the opposite of combination. Here you have one reactant and it's breaking down. It could be breaking down into two or even more than two products. So this is basically like decomposition, what's going on in your composter, even decomposing, breaking up. Okay, so here is an example. This isn't one that's going on in your composter, but we've got mercury oxide. So it's in a lattice structure as well. So right down here at the bottom of this test tube. So mercury oxide, it's a solid. You can tell from that S right here. So the mercury oxide, you've got your lattice of mercury and oxygen. It's going to break into its components. So then we've got mercury, and that's a liquid. So remember, if you look in your thermometer, mercury is special because it's a liquid metal. And then you've got oxygen gas. So that's where these bubbles are coming from. Okay, so breaking one reactant, breaking into two or more products. So that's decomposition. Now let's look at another one called single replacement. So in this one, you've got a single atom or an ion, and it's replacing an atom in a compound. So let's look at an example here. So in this example, we've got a beaker. It's got zinc in it. So this strip right here, that's zinc. And then this is a close-up, again, a lattice structure of a bunch of zinc atoms there. And then it's in a solution here of hydrochloric acid. So in this, we've got hydrogens and chlorides floating around. Remember, if something has an AQ behind it, that means it's aqueous, and so it's got ions floating around in it. Okay, so then what happens is this zinc comes in and it replaces the hydrogen. Okay, so it just kicks it out and then forms zinc chloride. So now zinc and chloride are together, not hydrogen and chloride. Okay, so now we've got a different compound here, and we've got hydrogen gas. So the hydrogen's been budded out and it's actually forming a gas. So you can see all the little bubbles forming on this zinc. So that's what's happened there. You've got hydrogen gas forming. Okay, so it's a replacement in that the zinc is budding out the hydrogen, and we don't have to look at the number of products and reactants. What we're looking at is anything pushing out or replacing. Okay, so that's a single replacement. And we'll look at a double replacement. So very similar to single, except now a double replacement is happening. So the way I think about it is you can look at the positive ions and their switching places, or you could look at the negative ions and their switching places. Okay, so here, if we look at this reaction, we've got sodium sulfate and then barium chloride. So that this injector here is injecting some barium chloride into the sodium sulfate. Okay, so we've got basically two aqueous solutions. So see the AQ there? So that means we've got two solutions where there's a bunch of ions floating around in these solutions. Then when these solutions come together, notice a solid forms here, and then we've got an aqueous solution. But it's not the same aqueous solution. It's not the same as the other two aqueous solutions. So look at what's happening. If I look just at the positive ions, so I look at the sodium and I look at the barium, the sodium in the beginning was in a compound with the sulfate. But look what's happened now. Now the sulfate is with the barium. Okay, so the sodium and the barium have switched partners basically, and now barium is with the sulfate. Okay, and now the sodium is with the chloride, so it's switched. Okay, so that's where the double replacement happens. You've got two things and they're switching places, and then you've got two new compounds formed. Okay, so that's a pretty interesting one, and we're going to look at that more closely in the next module. Okay, and then the final one is the combustion reaction. So combustion reactions are really important to humans. In a combustion reaction, you take fuel, and it can be any type of fuel, but these are basically carbon-containing or hydrocarbon compounds. So the alkanes that we talked about in the organic chemistry unit. And basically what's happening, they're burning an oxygen, and then they're producing carbon dioxide, water, and then energy, and the energy will be in the form of a heat or a flame. So this is the kind of thing that's going on in your car or your furnace. Anything that's producing some heat and flame could be a combustion reaction. So in a combustion reaction, you've always got to start with some kind of hydrocarbon. Oh, I just lost my thing here. Okay, you've got to start with some kind of hydrocarbon. So right here, this is my hydrocarbon. It's got carbon and hydrogen. It could be all different alkanes that we've talked about. And then you've got oxygen. So oxygen's always going to be there. And then you're always going to end up with carbon dioxide, and you're always going to end up with water, and then some type of energy is going to be formed. This isn't always written in your chemical equations, but in this one it is, so energy is formed. Sometimes that doesn't show up in your chemical equation. So always make sure that you've got these three things, the oxygen, the carbon dioxide, and the water, and then you'll have some form of this hydrocarbon. And here's an example, a nice glacial river, I think, here. And then somebody is using probably naphthalene or white gas, and then heating some food there for their backpacking expedition, I guess. Okay, so combustion reactions very important to humans and how we currently live, I guess, in our society. And then even a campfire really is a combustion reaction. The fuel is the wood, and then it is producing carbon dioxide and water and energy. That's what the fire is. Okay, so well done, Miigwech. In the next video, we'll be able to look at chemical equations and then classify them just based on looking at the chemical equation. Okay, till next time.